Problem 216, Classical Mechanics. The question is, a body of mass m is acted upon by a central force F of r is equal to minus kr, where k is a positive constant. If the magnitude of the angular momentum is L, then the total energy for a circular orbit is. In the present problem, the central force F of r is given, the value is minus kr, and we have to find out the total energy corresponding to the circular orbit. This problem is from the section central force. It is given that F of r is equal to minus kr, where k is a positive constant. Now let us write the condition for central force. What is the condition for central force motion? For a central force motion, the total energy E is given by half m r dot square plus L square by 2m r square plus V of r, where V of r is the potential. Here, the first term, half m r dot square, that is called the radial kinetic energy, and the remaining terms together we will call it as the effective potential V effective. The effective potential is L square by 2m r square plus V of r. Therefore, we can write energy is equal to, the total energy is equal to half m r dot square plus V effective. Now, we have to find out the expression for total energy in circular orbit. Now, for circular orbit, the radial kinetic energy, that is the first term, is 0 because the term r is fixed. Therefore, r dot is equal to 0. Therefore, the radial kinetic energy is 0 in the case of circular orbit. Therefore, the total energy becomes V effective only. That is, E is equal to V effective is the expression for the total energy in the case of circular orbit. Now let us go to the condition for circular path. Now for circular path, please remember that dou by dou r of V effective at r is equal to r0 is equal to 0. Now what is V effective? This is L square by 2m r square plus V of r. That is dou by dou r of L square by 2m r square plus V of r, that is equal to 0. Now differentiate this expression, we will get at r is equal to r0 is equal to 0. That is L square by 2m into minus 2 by r cube plus dou v by dou r at r is equal to r0 is equal to 0. 2 and 2 cancels. Therefore, minus L square by m r cube plus dou v by dou r at r is equal to r0 is equal to 0. Is equal to 0. Now what is dou v by dou r at r is equal to r0? We know that for central force, this force is equal to minus dou v by dou r. It is already given in the question that this f of r is equal to minus kr. Therefore, we can write dou v by dou r is nothing but kr. Dou v by dou r is nothing but kr. Now substitute the value of dou v by dou r in this equation. Remember, we are evaluating everything at r is equal to r0. Therefore, our expression becomes minus L square by m r0 cube plus k r0 is equal to 0. Now let us simplify the expression. K r0 is equal to L square by m r0 cube, and this implies that r0 raised to 4 is equal to L square by mk or R0 square, that is equal to L by root mk. L by root mk. We have R0 square is equal to L by root mk. Now we have to find out the total energy for a circular orbit, and we have already seen that this total energy is nothing but the effective potential. So E is equal to V effective, that is equal to L square by 2mr square plus V of r. We have already seen that dou V by dou r is equal to minus kr. Dou V by dou r is equal to kr. Therefore, we will get V of r is equal to half kr square. V of r is equal to half kr square. Now at r is equal to r0, V of r is half kr0 square. Here we are evaluating the energy corresponding to r is equal to r0. We have already seen that r0 square is equal to L by root mk. Now substitute everything in the equation for the total energy. We will get E is equal to L square by 2m r0 square plus half k r0 square. That is, at r is equal to r0, the total energy E is equal to L square by 2m r0 square plus half k r0 square. We have r0 square is L by root mk. Therefore, let us substitute the value of r0 square in the equation for E. So you have an equation like this. Now let us simplify the expression. E is equal to 1 by 2 L into root of k by m plus 1 by 2 L into again root of k by m, and this simplifies to L root k by m, and that is equal to root of kl square by m. Root of kl square by m. Therefore, the total energy for a circular orbit is E is equal to root of kl square by m. Therefore, option 4 is the right option.